Some of you might already taking control class. Oh, I know this very well. Why do you want to spend time with this? Well, we'll see what's going on here soon, very soon. Because many control engineers misunderstand about the discrete time. Sometimes you can use discrete time model, sometimes you cannot, depending on your assumption. So you have to be careful of your assumption. This is the key assumption. That you have to satisfy. That you have to satisfy. That you have to satisfy all these conditions before you can use the discrete time model. If those are not satisfied, you apply discrete model, then you will be subject to error. All right. Now, why, if I do this, what happens? Initially, I have differential equations. Now, I have only algebraic equations. Right? Because I integrate already. I already integrate those. This is differential equations. That is algebraic equations. That is algebraic equation. That is algebraic equation. This equation means that my next state will be the function of previous state and previous input. Right? My next state can be computed by the previous state and the previous input. That's all. Okay. You still have no questions. All right. I don't know why I got this E, but this is Microsoft problem, not my problem. All right. Now this is the chart. Important chart. The force degree discretizations. I call force discretizations. The sine wave. This is a sine wave. If you discretize it, means at every sample period of time, they are constant. So, when you use a computer to apply a force to a system, in matter of fact, you apply this discrete input, a zigzag discrete input. It's not like this continuous input. So you apply a sine wave to input. If you use a computer, you really apply to the computer with this like ladder step or zig step. I call zigzag step functions. So you are applying zigzag. It's not continuous. Understand about that now? Don't you worry about this? My system, if I have a system, I like to have continuous force. How come I just and then hit me once, and once again? But you got no choice. That's the nature. If you have discrete time model, you're gonna suffer with this. Of course, you might add a filter there. Somebody say, "Oh, I add a filter there to smooth it out." Yes, you could do that. But if you do that, that means your controller design is different. All right, that's the conditions. So to use the discrete time model for your controller design, first of all, you have to satisfy this. That means you have to satisfy these conditions. At every single period of time, they are constant. Okay? They are constant. If this is not satisfied, your discrete model is not right. Okay, now, if I give you only the one state, now the multiple state, if this is the matrix, AC is a matrix, BC is a matrix, and all are matrices, then what can I do? And the same thing, this is a vector now. That's a vector. The same thing you have to say, okay, ut equal to u0, that's a vector, that's a constant vector, from 0 to delta t. From delta t to delta t to delta t, then ut is still a constant, u delta t. Alright, from ut, t take delta t and k plus 1 delta t, then ut equal to uk delta t. If that's the case, discrete time model become this. This is for single state. For multiple state, AC replaced by cap AC, BC replaced by cap BC, and T replaced by delta T. This is, I have a delta T here. I replaced by identity n by n. Then that's your multiple state discrete time model. That's it. I did not use a matrix equation to derive discrete time model for you, because that's very complicated. Also, it's not easy to understand. That's much easier to understand. Don't you think so? This is why in here I did not use divided. I used AC inverse, because I want to mimic again from multiple states to the only one state case. All right. So this has become matrix inverse. That's a matrix inverse. A, C, T, I, C, and so on. And then if we simplify the form, ignore this delta T, because no delta T we can ignore it. We know that's delta T. Then that's the common way to write discrete time model. X k plus 1 equal to AXK plus BUK, just like what I wrote for you, that the continuous time model. But this is the X dot. This X k plus 1 is equal to A times XK. That's k plus 1, the previous state, plus B times UK, that's the previous state. But however, this UK has to satisfy the discrete nature. The chart I show you in last slide. You have to satisfy with this. If you satisfy with that, then this is we call discrete time model. Okay. Now, did you see any error? Anything wrong with these equations? Or it's good? Well, whatever the teacher write it, it's all good, right? Okay. Now, A will be computed by this, no problem. E, AC, delta T, matrix inverse, a matrix exponential, no problem, right? All right, and this one here, B will computed by AC inverse, parenthesis E, AC, delta T minus I, n by n, and then parenthesis BC. B it can be computed by this. Then what is the problem there? Do I have a problem to do that? Now, what is the AC for rigid body motion? Anybody can tell me? The AC for rigid body motions. What is AC? AC is equal to 0, 1, 0, 0. Right? That's my AC. Agree? Then what is my AC inverse? Huh? What is my AC inverse? What is AC inverse? What is AC inverse? What is AC inverse? What is AC inverse? Anybody tell me what is AC inverse? Huh? Oh, you might say, I need a minute. I need a side app to invert it. Go ahead. Huh? What is the determinant of AC? Huh? 0. That means AC inverse what? Does not exist. Right? Agree? So that means AC, if this is rigid body motions, I don't have discrete time model. Do I? Well, discrete time model. How can I get a discrete model for the for rigid body motions? See, you don't depend too much on math. You know, math sometimes can give you misleading results. So this combination only exists when AC inverse exists. Agree? Did I do anything wrong when I divide these equations? Did I? No. And what's wrong with me? Mathematical problem? I would get Nobel Prize if I say not a mathematical problem like this. Now what is the problem with this? All my derivations, you agree, right? Everybody agree with me. You didn't raise any questions? Hey. When you apply a formula, be careful. Be careful. The rigid body motions, you can apply this. When AC is